Hey guys, and welcome back to episode 5 of How to LeetCode with Jeff. I'm your host. So, this one is going to be a rather fun one. And a preface is that, I learned what a Pangram was in one of my upper level classes, I remember, where we had to do this for an assignment, right? It's basically starting to, hey, learn. Maybe these upper level classes are teaching us about like algorithms, complexity, and a little bit more LeetCode style. And funny enough, I actually learned this solution in OCaml with pattern matching and such. However, we're not going to be going over the pattern matching in OCaml today. We're just going to be coding this solution up in Python and talking a little bit about the different solutions that we can come up with. So one solution, you can actually solve this problem, I think, in one line of code where you just let's go back. A pangram is a sentence where every letter of the English alphabet appears at least once, meaning that it could have more than one. Like A could appear 3 times, 5 times. It doesn't really matter. Um, the thing is with this is that if we turn it into a set and then measure the length, if it's equal to 26, which is, the English alphabet has 26 letters, then we can immediately know if the pangram is true or false. But that solution um, is something that I want to touch on because your first intuition while solving this problem might be to, at least for me, I remember I wanted to like, okay, there's another string problem, right? We're probably gonna have to go through this. However, there's an easier way where, as you can see, I have like, why do we have this string over here, right? Why do we have all the letters of the alphabet? We're actually going to be iterating through the entire alphabet, right? So here we go. Let's jump into the coding. I don't think we need a whiteboard for this one. Uh, for character, for each character in the alphabet, if the character is not in the sentence, we can immediately return false because it has all of these letters have to gotta appear, right? So if the character is not in the sentence, we're done. And you could just return true after. And I believe this should be good. Yep. And that's all it is you have our base case, and then there also is one more solution where you could turn essentially A, I believe, is 97 in ASCII. So what we can do is normalize that value by we're gonna subtract the current. We would subtract the uh current. Let me type here. Current character subtracted by the ASCII value of A. So 97 minus 97, like it'd be 0. So we know that 0 is A, B is 1, and then so on and so forth. That's actually a pretty cool way to use bit mask, and we'll be touching on that like in some other problems where we talk about bit manipulation. But yeah, um, that is how to solve. Check if the sentence is a pangram. I will see you guys in the next one. Peace.